In the last section, we made an entire functional game of Pong, and we learned how to access map our movement keys to a paddle or an object. We created an AI paddle, which moves on its own and tracks a ball. We created a ball, which collides with certain objects and keeps score. Let's take a look at what we're up to in this section. In this section, we're going to add some polish. We're going to modify our feel, and we're going to modify our paddles. We're going to implement a scoring system. We'll discover impulse and what that is and how to add it to our game. We'll take a look at creating pinball pop bumpers and multi-ball. We'll implement a game clock and have it count down, and then lastly we'll wrap up by adding some particle systems and adding some fun to our game. Lastly, we'll wrap up. Okay, in this video 3.1, keeping score, we're going to modify the game from a new perspective. We're going to get rid of the top-down camera and add a new perspective to our game. We're going to add our polish. We're going to discuss text render components and how to implement a scoring system with those text render components. Let's get started. Before we start moving ahead with modifications, I highly recommend that you implement your own creative style in your color choices and mechanic changes throughout this section. Feel free to follow along with just this though to get a feeling as to how easy it is to just make an interesting game by changing a few simple things. So first things first, let's grab the floor and change its z-axis value to a value of -40 centimeters. This raises the floor and brings it to almost an intersection with our boundaries. So next, let's go ahead and change the material for the floor. Not under the mesh folder, under materials. There we go. Now you see we have a bunch of materials here that I've already made. We will be going into those as the coming minutes pass. But for now, just open up m_playfield and let's modify its roughness value from a value of 1 to a value of 0.1. Let's hit apply and save. And you can see our material is now no longer matte, it is glossy and reflective. So let's go back into the main level and simply drag and drop. Now when we change the plate view mode from unlit to lit and zoom over to a boundary here, you can see that we have some nice glossy reflections going on from the emissive texture. Very cool. Okay, next let's take a look at the player start and see that I have modified it a little, and all I've done is just change the scale from a value of 1 on Z to a value of 0.5. This way it does not intersect our floor, and if we hit play and I press W and S, you can still see that we are moving and not stuck in the ground. So that takes care of that. Pretty simple. Next, let's go ahead and open up the level blueprint. And let's just go ahead and hover your mouse over the connection, then Alt and left click to break the connection between event begin play and assigning our overhead camera. So with that severed, we can hop into the BP paddle P1 and let's modify our player paddle a little. So in the viewport, you can see we have this classic paddle. Now this is really cool, very standard. Let's change this to something that is hopefully a little cooler. So in your content browser, under the mesh folder, I have made a 3D model called SM_UE4 Pong paddle. If we open this up, you can see that it is using a mask to essentially produce an emissive wireframe, and then I've masked off the front polygon face to just glow normally. And then on the back here is where we're actually going to be displaying the score via TextRender. We'll get into that in a few moments later in this video. But for now, let's check its collision. And you can see I've already gone ahead and added a collision, add box simplify collision, and that's all we needed to do for this. Now, let's go ahead and, yes, it is selected, and apply it to our current paddle by selecting the static mesh and just using the content browser asset. And you can see it brought in the material with it, since this is the material that is saved with this static mesh. So that's great. Let's compile. And let's go ahead and add a camera. So add component, add our new camera, not a cine camera, just a regular camera. And let's push this back into space and rotate 90 degrees. There we go. We want it to face the front. And we'll raise this 80 degrees, or excuse me, 80 units in Z. And let's push this back to, say, 320. And let's put it at a value of 0 on X just to make sure. And now before we X out of this, I want us to take a look at field of view, and I'm just going to bump it up to a 120 degree field of view so our game isn't so cramped. We're going to open up the perspective. So let's compile. And when we hit play, we now have a camera that is behind our paddle. We have a new 3D Pong game, and our camera is actually following the paddle without any extra code. Now, if we hit escape, why is that? Well, the simple answer is that the camera is a child of the parent. It's sitting nested in the hierarchy. So there's nothing that needs to happen. There's no special trick. It's simply just following the chain of command. So we can save this. We can X out. Now, I'm still using W and S to move, and that doesn't feel quite right. Now that we're moving left to right as opposed to up and down, or the main reason why we programmed our game to run on X as opposed to running on Y, needs to change. So, let's go to Project Settings. Under Engine, under Input, let's make this correct by changing W to A. And that binding has changed, and changing S to D. And now, when we X out, and just go ahead and play, it's as easy as that. Now A and D control our paddle. Okay, now I'm actually going to hop back into the paddle blueprint. The camera seems to be a little bit off, so I want to bring that in a little tighter. So grab the camera, just go ahead and do this. And let's, 290 should be fine. Just a little tighter. And save, and X out. Okay, now the next problem is that our ball is the same color as everything else. So that's fine in 2D when you're playing a top-down. You can tell where it's going to go. But in 3D, it's a little difficult to tell. So in the materials folder, all I've done is created an M_ball material, and this is a copy or a duplicate of M_boundary, and the only difference is that I've changed the color and then increased the emissive value. So let's go ahead and X out instead of waiting for the preview. Let's press F and zoom over, and simply use a different method to apply the material. Let's left click and drag directly into the material slot under details, and there you go. Now, again, hit play. And now that ball is much easier to see. Okay, let's X out. Now, the roof or the expansive universe above us is kind of distracting, and we don't have a lot of positive space being taken up by our meshes. We need to close that off. So let's go ahead into the mesh folder, and I have created a mesh called, or a 3D mesh called SM_playfield dome. And if we drag this in, and just reset its transform and change to unlit, you can see that it is just a cylinder with 2 raised edges that I've modified, and it just runs the length of the arena. Now let's go ahead and take a look at the material I would like to use for this. Now I've made a material called M_playfield dome, and we open this up. You can see it's using the methods that we've used before, taking a vector 3 and using it for the base color and the emissive by multiplying. But we have the added benefit of using a mask in this, and this is in the starter content. This is T-Tech Panel M. Now, just like in the PBR lesson we had in section 1, you can use masks or gray packed masks or P-masks, or there's so many various terms for it, to use individual color channels within your texture to drive multiple changes within your material. So if I zoom out here and I switch to plane mode, you can see that the texture masks or the red channel is being multiplied by our vector 3 and used for the emissive and base color. So anything that is red or stored in the red channel will show up as blue and glowy. Now I'm using the alpha channel to drive the roughness. So the majority of the black surface is rough, but the creases between the glow panels and the interior is pretty glossy. So that's simple and an easy way to make your materials a little more interesting just by using one texture sample alone. Now let's talk about this texture coordinate. Now what this does is it allows us to control the U tiling and V tiling, or the horizontal and vertical tiling of a texture sample. So say I were to change this to a value of 1, the texture sample is now returned to its original state, since textures are stored between 0 and 1. But let's bump this back up to something, say like 5, and now it will tile horizontally 5 times. Likewise, if I were to do 5 on vertical, now we have equal distortion across all fields, and we have this cool little square tile text pattern. Now I'm going to change this back to what we were going to use, and that is 2 on U and 1 on V, and just apply and save and leave. Now let's just go ahead and drag and drop this onto the dome and switch back to lit mode. And look at that. Now that we have a reflective floor and a glowy surface for our arena dome, we have this really cool Tron arena aesthetic. Almost looks like a Stormtrooper Imperial docking bay. It's pretty neat, and it's very simple to do. So, moving on from there, now comes the time to implement our change in score and where to display it. So, let's hop back to UE4 Pong, and let's go into the Blueprints folder. Hop into BP Paddle P1, and as we discussed, we want to display the score on this back panel up here. Now, let's go ahead and do that by adding a component, which is a TextRender. And we're going to call this score P1. And we're going to add another component, another TextRender. And we're going to call it score CPU. And let's mess with score P1 first and move it into position. So let's right about there, let's rotate 90 degrees and align it with the angle of the surface, which is just about 80 degrees. And you can see I'm moving on local space. We can switch to world or local, and world is much more easier when modifying components within your blueprint. So that looks to be like a decent placement. Now let's scroll down and change the default text and hit Control A and change it to 0 since we're going to be representing integers. And let's bump it right about there. And let's change the horizontal alignment to center as well as vertical. So now we have a centralized pivot and we can control this a little better. Okay, next, world size. Let's bump this up to say 120. Oh, way too big. Sorry about that. Let's scroll down to 64. Yeah, 64 should do. Okay. Let's scroll that back down in the bottom. Since we do have our camera pretty low, the angle is actually going to help us push this to the bottom, and it's still going to be readable. So let's grab our score CPU and do the same thing. So we're going to drag up, rotate 90, rotate 80, and just drag into place. There we go. And let's do the same thing. Control, set to 0, 64 for the size, and oops, get out of this. Change our alignment to centers. There we go. And just move this into place. Yeah, what's our CPU or our player one at? So that is at 36 on Z. So let's go ahead and change that. And let's put this at -30 and 30. There we go. All right, that'll do. Okay, now you can see on the left that, or excuse me, on the right, that these text renders are using default text material opaque. Now, if I find this in the content browser, you can see this is stored under the engine content. This isn't normally visible to users unless you select a material like world grid material or the default material and then search for it. Then you have access to all of this stuff. Now, to ensure that everything goes smoothly, what I've done is just hit Control C and Control V inside of our materials folder and created two materials called default text material opaque CPU and default text material opaque player. And if I open this up, you can see that the default material is just the vertex color, the lerp, and the font, and just plug directly into base color and opacity mask. The modifications that I have made is just multiply it by a vector 3 so we get a blue and a purple material, and multiply the base color value by 5 to get the emissive glow. So let's go ahead and X out of this and apply these materials to our TextRender actors. So first things first, for score P1, apply the blue, and we'll have our purple be CPU. So we can just select this and change it. And there we go. Cool. Okay, now we can't actually have the score update on our BP paddle P1. We could, but it's not going to work right now. The logic for the score isn't contained here. It's contained within the game ball. So let's hop over to that and just modify it there. So in Blueprints folder, open up BP game ball. And let's zoom out here and see what we have. Okay, so where's the logic contained for scoring? Within the goal left and the goal right. So we need to go ahead and select everything past the delay. And we're just going to drag it out into space here because we're going to be putting a chunk of code right in the middle here. So for score CPU, yes, we need to drag off of the delay and get all actors of class and search for our BP paddle P1, which contains the text renders for our score display. So from this, we need to do a for each loop to find our actor. And from here, actually, we're going to have to space this out even further. Got a little more code to go. There we go. Okay, as the array element, we can drag this out and get the variable we want to use, which, since we're modifying the score CPU, we should search for the score get score CPU text renderer. And from here, drag off and set text. You can see we have the options of render color, material, but we just want to update with our score value. So just set text is absolutely fine, and we'll drag this off of the loop body, and we will left click and get our variable score CPU and just drag it into the set text. And you can see it has already converted it to a string value by 2 text nodes. Okay, so we can just left click and set our actor location again to reconnect the chain. And all we have to do is we can just use the same get all actors of class node. Yes? Yes. Oh, look at that. Minimizing code. Very cool. So this chain will stay up here, but the for each loop and the get all actors of class can come down here and act as a bridge. So we're still referencing BP paddle P1. Now we need to take care of the player score. So off of target, search for score or get score P1. And we can just duplicate the set text. And off of the loop body, there we go. Okay, so we do have the problem when we do branch this that we need to run something at the same time. So let's drag off of loop body and run a sequence. And what sequence does, if you don't remember, is it executes a series of pins in order, but it's so fast that it actually executes them at the same time. So we want to set text and set text, and there we go. Okay, so we need to get the score player value and update it. So get it, convert to text, reconnect our chain, and it's as easy as that. So let's compile and let's go ahead and play, and let's try and score here. AI looks like it's got a handle on it. Yep. So we got to do a little better job here. Come on, give me a good bounce. There we go. And we have a score of 1. We let it go by. CPU has a score of 1. And that is a functional scoring display. Very cool. Okay, that's it for this video. Let's summarize what we've learned. Alright, very well done. We now have a scoring system that is fully functional. In the next video, we'll talk about impulse and we'll have some fun with physics. See you there.